Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Chemical Kinetics. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section, so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told which of the following statements is in accordance with the Arrhenius equation. So the Arrhenius equation is given as K equals to A e power minus Ea by RT, where Ea is the activation energy and K is the rate constant and A is the Arrhenius constant. So here, as the temperature increases or the activation energy decreases, the rate constant K increases. So the rate constant, the rate of the reaction increases with the decrease in activation energy. So option D is true. And then it is told in option A, rate of a reaction increases with increase in temperature. That is also true. And in B, it is told rate of reaction does not change with increase in activation energy. That is wrong. Rate constant decreases exponentially with increase in temperature. That is also wrong. So the rate of reaction increases with the increase in temperature and with the decrease in activation energy. So options A and D are correct answers. Then it is told which of the following statements is incorrect. When it is told that which of the following statements is incorrect. So here it is told um, molecularity is only applicable for elementary reaction. So it is a true statement. Okay. Rate law for any reaction cannot be determined experimentally. That is false. Then biomolecular reactions involve simultaneous collisions between two species. That is true. And complex reactions have fractional order. That is also true. So option B is the wrong statement. So it is the correct answer. Since the rate law for a reaction can be uh, uh, determined experimentally, since if we know the concentrations, then we can find out the order of the reaction. Then for the reaction 2SO2 plus O2 gives 2SO3, the rate of disappearance of O2 is this, then the rate of appearance of SO3 is. So here we can say the rate of disappearance of SO2, that is equal to the rate of, so half of the rate of disappearance of SO2, that is equals to half uh, of the appearance of SO3, rate of appearance of SO3, and that is equals to the rate of disappearance of O2. So therefore, here it is told that the rate of disappearance of O2, that is equal to 2 into 10 power minus 4 mole per liter per second. So therefore, the rate of appearance of SO3, that is half the rate of appearance of SO3, that is dSO3 by dt, that will be equal to half of 2 into, no, that is 2 into will be 2 into 10 power minus 4, that is equal to 4 into 10 power minus 4 mole per liter per second. So option B is the correct answer. Then it is told that the temperature coefficient of a reaction is 2 when the temperature is increased from 30 degrees Celsius to 90 degrees Celsius. The rate of the reaction is increased by. So now the temperature coefficient that is equal to 2, it means that the rate of the reaction increases to twice, or the rate of the reaction doubles itself. Rate of the reaction doubles itself when there is a 10 degrees Celsius increase in temperature. When there is a 10 degrees Celsius increase in temperature, now therefore when the temperature increases from 30 degrees Celsius to 90 degrees Celsius, it means that there is a 60 degree Celsius rise in temperature, 60 degrees Celsius rise in temperature. Therefore, it means that the rate of the reaction is 2 power 6 times the rate of the reaction will be 2 power 6 times uh, so the rate of the reactions will be increased to 2 power 6 times of the initial rate. 2 power 6 means 64 times. So option D is the correct answer. Then it is told the value of rate constant of pseudo first order reaction that depends only on the temperature. So option A is the correct answer, that the rate constant K of a pseudo first order reaction, it depends on the temperature only for pseudo first order reaction. Then it is told the plot of half-life T half versus the initial concentration R naught for a reaction is a straight line parallel to x-axis. Unit for the rate constant of this reaction is. So the plot of T half versus R naught is a straight line parallel to the x-axis. It means that it is independent of the initial concentration. It is independent of the initial concentration. So therefore, it means that it is a first order reaction. The first order reaction, it means that, as we know, that minus dA by dt, that will be equal to A, or I can say K will be equal to ln 2 by T half. So it means that the unit for the rate constant K, that will be equal to per second. So option D is the correct answer. Mm. When it is told which is a wrong statement, the rate constant A, uh, if the activation energy equal to 0, then the rate constant K equal to Arrhenius constant A. As we know, K equals to A e power minus Ea by RT. So if the activation energy is 0, then obviously K will be equal to A. So it is a true statement. Then it is told e power minus Ea by RT gives the fraction of reactant molecules that are activated at a given temperature. So it is a true statement. Since K by A, that will give us the, which is equal to my e power minus Ea by RT, that is equal to the fraction of the reactant molecules that are activated at a given temperature. It means that the number of reactant m- molecules, activated reactant molecules divided by the uh, total number of reactant molecules, total number of reactant molecules. So it will be equal to the fraction of the reactant molecules that are being activated at a given temperature. So now it means that if I write ln k will be equal to ln A minus Ea by RT. So the, therefore the graph of ln k versus 1 by t is obviously a straight line, a straight line graph. And presence of catalyst will not alter the value of the activation energy. That is false. Since why, if catalyst is present, then it will change the value of the activation energy. It will actually decrease the value of the activation energy so that the reaction can happen more faster. So option D is the wrong statement. So it is the correct answer. Then it is told 1 liter of 2 molar CH3COH is mixed with 1 liter of 3 molar C2H5OH to form an ester. Here ester will be formed, which is CH3COO C2H5. So now the rate of the reaction, which with respect to the initial rate, when each solution is diluted with an equal volume of water, will be. So now therefore the initial rate R1, that will be equal to K into the concentration of CH3COH times the concentration of C2H5OH. Now, so the initial concentration is 2 molar for CH3COH and 3 molar for C2H5OH. So this will be K into 2 into 3. So that is 6K. R1 equal to 6K. And R2, which is the final rate after each solution is diluted with an equal volume of water. So the new concentration, now therefore we can say the new concentration of CH3COH, that will be equal to, so now here it is told 1 liter of 2 molar of CH3COH is taken, so 2 moles. 2 moles by equal volume of water is added. It means that 1 liter of water is again added. 1 liter water is added. to this. So the total volume of the solution will be 2 liters. So therefore it will be 1 molar is the new concentration of CaCO(H), and similarly the new concentration of C2H5OH will be uh, 3 into 1 liter is used. So since we know that the number of moles is molarity times the volume in liters. So here 3 moles of C2H5 is used, and here equal volume of water is added. So 1 liter of water is added again to this. So the total volume is 2 liters. So 3 by 2, so 1.5 molar. So therefore the final rate or the new rate of the reaction, that is equal to K into, since the rate constant will not change, K into 1 into 3 by 2, so that is equal to 3 by 2K. So this we can write 6K into 3 by 12, or I can say 1 by 4, 6K into 1 by 4. So it means that it is R1 by 4. So it means that the initial, so the final rate is 1 by 4 times of the initial rate, means 0.25 times R1. It means the rate of the reaction with respect to the initial rate is 0.25 times. So option A is the correct answer. Then it is told the time required for 60% completion of a first order reaction is 50 minutes. So therefore 40% of the reactant is remaining. 40% of the reactant is remaining. Therefore, therefore since it is a first order reaction, it is a first order reaction, so I can say that A will be equal to A naught e power minus KT, where K is the rate constant and A naught is the initial concentration and A is the final concentration at any time t. Now therefore at time t equals to 50 minutes, it is told that the A will be equal to 60% is completed. So it will be 40%, so 0.4 A naught. And it is asked to find the time required for 93.6% completion of the same reaction. Now, therefore, we have to find out the time t1 at which A will be equal to so 100 minus 93.6, that is equal to 6.4% of A naught. So that will be equal to 0.064 A naught. So that time will be how much? That is being asked. If I can tell 0.4 A naught equals to A naught into e power minus k into 50 minutes. So from here we can find out the value of the rate constant k in minute inverse. So therefore A naught will cancel. Then we can say ln 0.4, that is ln 4 by 10, that is equals to minus k into 50. So this is 2 by 5. So I can say k will be equal to 1 by 50 ln 5 by 2. So this is the rate constant. So therefore the rate constant k is equal to 1 by 50 into ln 5 by 2 in minute inverse per minute. So now in time t1 has been asked at which a is equal to 0.064 naught. Therefore, 0.064 A naught, that is equals to A naught e power minus k into t. So 1 by 50 ln 5 by 2 k into t1. T1 is has been asked to find out. So A naught will cancel out. And we can say, so ln 0.064, that is equals to uh, minus 1 by 50, means T1 by 50 ln 5 by 2. So this is actually ln 64 by 1000, or I can say ln 1000 by 64. That is equals to T by 50 ln 5 by 2. Now this is 4, or I can say 8 8 is 64, 8 1 is 8, 2 is 16, 5 is 40. So therefore T equals to 50 into ln 125 by 8 divided by ln 5 by 2. Or I can say that this will be 50 into log base 5 by 2, and and means it is actually log of 125 by 8, log of 125 by 8, log log of 125 by 8 base 5 by 2. Now 5 by 2 whole power 3, that is equals to 125 by 8. So therefore this value will be equal to 3. So this is 50 into 3 minutes, that is equals to 150 minutes. So at t equals to 150 minute, I can say that 93.6% of the reaction will be completed. So option C is the correct answer. Then it is told, for an elementary reaction 2A plus 3B that gives 4C plus D, the rate of appearance of A, no, the rate of appearance of C, it means dC by dt at time t, that is equals to 2.8 into 10 power minus 3 mole per liter per second. And the rate of, then the rate of disappearance of B at t will be. Now the rate, so 1 by 3 times the rate of disappearance of B, that is equals to 1 by 4 times the rate of appearance of C. So therefore the rate of disappearance minus dB by dt, which is the rate of disappearance of B, that will be equal to 3 by 4 times the rate of appearance of C. So that will be equal to 3 by 4 into 2.8 into 10 power minus 3 mole per liter per second. So this will be equal to 4 sevens are 28, 7 threes are 21. So 2.1 into 10 power minus 3 mole per liter per second. So it means it is 3 by 4 times. So option A is the correct answer. Then it is told, the rate constant of a reaction is given by K equals to Pz e power minus Ea by RT under standard notation. In order to speed up the reaction, which of the following factors has to be decreased? So if we take log on both sides, then we'll get log K, that is equals to log Pz minus Ea by 2.303 RT. Now here, now if we, so in order to speed up the reaction, in order to speed up the reaction, the rate constant should be increased. The rate constant should be increased. So it means that we have to increase the value of Z, and we can decrease the value of Ea, the activation energy. or we can increase the temperature. We can increase the temperature and we can increase the value of z, or we can decrease the activation energy. Then the rate constant will increase, and so the it will speed up the reaction. It will increase the rate of the reaction. So therefore, EA has to be decreased, the activation energy. So option B is the correct answer. Then it is told that for a reaction A plus 2B gives products when concentration of B alone is increased. Half-life remains the same. If concentration of A alone is doubled, rate remains the same. The unit of rate constant for the reaction is. So it means that the rate of the reaction, which is minus dA by dt, or I can say minus half of dB by dt, which is the rate of the reaction rate. Now, rate of the reaction, uh, that is proportional to the concentration of B, since why its half-life is independent of the, since why here half-life is independent of the concentration of B, independent of the concentration of B. So it means that the rate is first order in B, and here it is told that if the concentration of A is doubled, then the rate remains the same. So it means that it is independent of the concentration of A. So it is order 0 with A, and it is order 1 with B. Therefore, the rate the rate of the reaction, that is equals to K into concentration of B. Now, therefore, the rate constant will be equal to rate means minus half of dB by dt into 1 by concentration of B. So therefore, the rate constant, the unit of the rate constant, that will be equal to liter per mole, means mole per liter inverse, or simply I can say here concentration of B mole per liter uh, by this is second by mole per liter. So mole per liter concentration will get cancelled. So unit of K will be per second. So option A is the correct answer. Then it is told if the rate constant for a first order reaction is K, rate constant for a first order reaction is K, the time T required for the completion of 99% of the reaction is. Mm. Mm. If the constant, rate constant K for a first order is K. So here it means that minus dA by dt, that is equals to K into concentration of A. So therefore concentration of A I can write that is equals to A naught e power minus KT. The time required for the completion of 99% of the reaction. It means that 1% of A naught is remaining. It means A equals to 1% of A naught, at which time that is being asked. So therefore 1% of A naught means 0.01 A naught. So therefore we can say 0.01 A naught equals to A naught e power minus K into T. If I can say ln 0.01, that is equals to K minus KT, or I can say this will be ln 1 by 100. So it is ln hundreds, or 2 ln 10, that is equals to kt. Now ln 10, we know that ln x, that is equals to ln 10 into log x. So therefore ln 10 is actually equal to 2.303, 2.303 log x. So ln 10 is 2.303, so t will be equal to 2 into 2.303 divided by k. So that will be equal to 4.606 divided by k. So it is the time required for the completion of 99% of the reaction. So option A is the correct answer. Then it is told that the rate of a gaseous reaction is given by the expression, the rate, that is K into concentration of A into B, concentration of B whole square. If the volume of the vessel is reduced to one half of the initial vo- volume, the reaction rate as compared to the original rate is. Now volume is reduced to half. Volume is reduced to one half of the initial volume. So therefore the concentration will increase to twice of the initial concentration. So therefore reaction rate means, suppose this is the initial rate, so now the final rate will be k into 2a, and this will be 2b whole square. So 4 to the 8, so it will be 8 into k concentration of A into concentration of B whole square. So it means the RF will be equal to twice of RI. It means the final rate will increase to 8 times of the initial rate. So the reaction rate will increase to 8 times. 8 times. So option C is the correct answer. Then here it is told higher order reactions are rare due to shifting of equilibrium towards reactants due to elastic collisions, loss of active species on collision, low probability of simultaneous collision of all reacting species, increase in entropy as more molecules are involved. Hmm. So here it is told higher order reactions are rare. So higher order reactions are rare because there is low probability of simultaneous collision of all reacting species. So option C is the correct answer. Then it is told a first order reaction is half completed in 45 minutes. How long will it need 99.9% of the reaction to be completed? Therefore, it means the half-life is 45 minutes. It means that half-life is 45 minutes, and since it is a first order reaction, it means that minus dA by dt, that is equals to k into A. So therefore half-life that is equals to k, means it is ln2 by k. So it means that half-life that is 45 minutes, that is equals to ln2 by k. So therefore k, the reaction constant k, that is equal to ln2 by 45 per minute, minute inverse. So now therefore how long will it take to complete? 99.9% of the reaction is completed. So it means that 0.1% is remaining. So therefore the final concentration, so if we solve it, then we'll get A equals to A naught e power minus kt, where A naught is the initial concentration of A. Therefore we have to add, so we have to find the time at which the final concentration is equals to 0.1% of the initial concentration of A. So at which time it will happen, that we have to find. 0.1% of A, it means that it is 0.001 A naught. So I can say 0.001 A naught, that is equals to A naught e power minus kt. So that t we have to find out. A naught will cancel out. Therefore we can say that ln 0.001, that is equals to minus kt. So therefore kt, that is equals to ln 1000. ln 1000 means 3 ln 10. 3 ln 10. Now ln 10 means 2.303. So t will be equal to so t equals to 3 ln 10 divided by k. So it is equal to 3 ln 10 divided by k, that is k is ln 2 by 45. So it is ln 2 by 45. So this much minutes. Means now we 3 into 45 into ln 10 is 2.303 and ln 2 is 0.693. So this we have to solve and find out. And here the options are given in hours. So this much minute we need to convert into hours. So this divided by 60. So 3 into 45 by 60, since 1 hour equal to 60 minutes. So into 2.303 by 0.693. So 15 threes are 45, 15 fours are 60. So 9 by 4 into 2.303 by 0.7 also we can tell approximately. So 7 threes are 21 and 0.3, 7 threes are 21 and 7 threes are 21. Approximately 0.33 into 4. So 4 eights are 32 approximately. So 9 eights are 72. So 0. Okay. Is 0.7. So point will be removed. So 2. So actually this is wrong, but there's something wrong here. So this will be actually 2.03 into 0.7 approximately. So point will be removed. So I can say it is 9 by 4 into 23.03 divided by 7 approximately. So 7 threes are 21 and 7 threes are 21 approximately. So in 4 eights are 32 approximately. So approximately it is 7.2 hours, slightly more than 7.2 hours. So it is 7.5 hours. So option D is the correct answer. Then here it is told that the rate of the reaction CH3COC2H5 plus NaOH means one ester is reacting with the sodium hydroxide, that will give us the sodium acetate and plus eth- ethyl alcohol or ethanol. So it is given by the reaction rate of the reaction is given as K into concentration of CH3COC2H5, which is ethyl ethanoate, times the concentration of NaOH. So if concentration is expressed in mole per liter, the unit of K is now, so now rate I can say this is equal to minus D of concentration. It is equal to minus of D of NaOH by dt. It means the rate of decrease in the concentration of NaOH. So therefore K will be equal to uh, so it is mole per liter divided by, so this is per second, by mole per liter whole square. So this will be mole per liter inverse per second. So this is liter per mole per second. So option A is the correct answer. Then here it is told for nth order of reaction, half-life period is directly proportional to, for nth order of reaction, half-life period is directly proportional to. So here we can see that for nth order reaction, we can say minus dA by dt, that is equal to K a power n. So therefore I can say minus dA by a power n, that is equals to K dt. So now we can integrate it from a naught to a and from this from 0 to t. So then it will come a power minus n plus 1 by 1 minus n. Then it will go from a naught to a. This will be kt. Now, so this we can write. This will be 1 by a power 1 minus n minus 1 by a naught power 1 minus n, which is equal to 1 minus n into k into t. So now therefore the half-life at which a naught a equal to a naught by 2, then it will come. So then it will come a naught by 2. So it will be 2 2 raised to 1 minus n minus 1, yeah, a naught by 2. Now here one minus sign is there, so you can write. So this will be, so it means that t half, that will be proportional to, so this, sorry, this will be n minus 1. This will be n minus 1. So t half, that will be equal to, actually it will be 2 power n minus 1 minus 1 by a naught power n minus 1 into k into k into n minus 1. This will come. So it means therefore the half-life, that is inversely proportional to, l- let's say if we take the initial concentration a naught as a, then we can say the half-life is proportional to 1 by a power n minus 1, or I can say it is proportional to a power 1 minus n. So it is either proportional to 1 by a power n minus 1 or a power 1 minus n. So options B and C are correct options. So options B and C both are correct. Then here it is told that half-life of a reaction is found to be inversely proportional. Half-life of a reaction is found to be inversely proportional to the fifth power of the initial concentration. Then the order of the reaction is. So now, therefore, we previously saw that the half-life the half-life is inversely proportional to a power n minus 1. It means the initial, it is proportional. So half-life is inversely proportional to the n minus 1th power of the initial concentration for the nth order reaction. For nth order reaction. So here, therefore, here I can say that this n minus 1 will be equal to 5. So therefore, n will be equal to 6. So it is a sixth order. So therefore, the order of the reaction is 6. So the reaction is 6. So option B is the correct answer. So here it is told that in which of the following reactions rate constant has the unit mole per liter per second. So, so it means that if the rate constant K has the unit mole per liter per second, it means that that minus dA by dt that should be equal to K. It means that it should be a zero order reaction. So the unit of K is mole per liter per second. So it means that it is a zero order reaction. So here 2NO plus O2, it is not a zero order reaction, and a decomposition of HI means hydrogen iodide on the surface of gold, it is a zero order reaction. The decomposition of HI hydrogen iodide on the surface of gold, this is a zero order reaction. So hence the unit of its rate constant is mole per liter per second. So option B is the correct answer. Then it is told that the rate constant for two different temperatures are K1 is 10 power 16 into e power minus 2000 by t, and the rate constant, second rate constant K2 uh, is 10 power 15 into e power minus 1000 by t respectively. Then the temperature at which K1 equals to K2 is. So if K1 equal to K2, it means that 10 power 16 into e power minus 2000 by t, that should be equal to 10 power 15 into e power minus 1000 by t. So therefore, this we can write, this will be 10 power 16 divided by 10 power 15. So this will be equal to e power minus 1000 by t divided by e power minus 2000 by t. So this will be equal to 10 will be equal to 10 power 15 will cancel out with 10 power 16 and 10 will come. So 10 will be equal to e power 2000 by t minus 1000 by t. It means it will be 1000 by t. It means that 10 is equal to e power 1000 by t. It means that 1000 by t, I can say that is equals to ln 10. Now ln 10 means it is 2.303. So 1000 by t is equals to 2.303. So therefore t equals to 1000 divided by 2.303 Kelvin. So option A is the correct answer. Then it is told for a reaction, the value of the rate constant K at 3000 at 300 Kelvin, that is 6 into 10 power 5 per second. The value of the Arrhenius factor at infinitely high temperature is. So as you know that K will be equal to Arrhenius factor A into e power minus EA by RT. So now the value of the Arrhenius factor will not change. So now it is told K into 10 power 5, that is equals to A e power minus EA by R into T. T is 300 Kelvin. So therefore we can say that the Arrhenius factor, that will be equal to 6 into 10 power 5 divided by e power minus EA by 300 R. That means that it will be 6 into 10 power 5 into e power EA by 300 R. So it means that none of the options are correct. None of the options are correct here. Only in the option C here, if we keep as plus EA by 300 R, then only option C will come. Then it is told that a radioactive isotope decays at such a rate that after 192 minutes, only 1 by 16 of the original amount remains. The half-life of the radioactive isotope is. So here it is told that so at 192 minutes, 1 by 16 of the original amount remains. It means that A will be equal to A naught by 16. The half-life of the radioactive isotope is T half, that is being asked. So the radioactive decay, as we know, it is a first order reaction. So as you know that a radioactive decay is a first order reaction. So therefore we can say that minus dA by dt, that will be equal to K into A, where K is the rate constant, or I can say it as radioactive decay constant. So therefore we will have that A equals to A naught e power minus KT. So therefore it is told that A naught by 16 is A, and that is A naught e power minus K into 192 minutes. So therefore we can say that this will be ln 1 by 16, that is equals to minus K into 192. So therefore K will be equal to ln 16 by 192. Now ln 16 means it is 2 power 4. 2 power 4, so it is 4 ln 2 divided by 192. So 4 the 16, 4 8 the 32. So therefore the radioactive decay constant K equals to ln 2 by 48. Now the half-life, therefore for half-life we can say that A naught by 2, that is equals to A naught e power minus K into T half. So A naught will cancel. So therefore K is equals to actually ln 2 by T half. So T half is equals, the half-life is equals to actually ln 2 by K. So therefore the half-life of this radioactive isotope, that is equals to ln 2 by K. K is equal to ln 2 by 48. So that is equals to 48 minutes. So 48 minutes is the half-life. So option 4 is the correct answer. Then it is told the velocity constant of a reaction at 290 degree Kelvin was found to be 3.2 into 10 power minus 3 per second. When the temperature is raised to 310 Kelvin, it will be about. Now, therefore, the value of the velocity constant or rate constant at 290 Kelvin, that is equals to 3.2 into 10 power minus 3 per second. Now, the rule is that for for 10 degree Celsius or 10 Kelvin rise in temperature, the velocity constant the velocity constant increases by 2 times. It increases by 2 times. It means that we can say the rate constant at 300 Kelvin, that will be equal to twice of the rate constant at 290 Kelvin. And so the rate constant at 310 Kelvin, that will be equal to twice of the rate constant at 300 Kelvin. It means that it will be 2 power 2 times the rate constant at 290 Kelvin. It means it is 4 times the rate constant at 290 Kelvin, which is 3.2 into 10 power minus 3 per second. So that will be 4 2 is 8, 4 3 is 12. So 1.28 into 10 power minus 2 per second. So option 2 is the correct answer. Then here it is told that which of these does not influence the rate of this reaction. So nature of the reactants, that will obviously influence the rate of the reaction. Concentration of, so as we know that the rate of a reaction, it is equals to K into concentration of A power N into concentration of B power M. If A plus B goes to C plus D, so the rate constant, the rate of a reaction, it will depend on the concentrations of the reactants, and it will also depend on the nature of the reactants. And since the rate constant, it will depend on the temperature of the reaction, so the rate will depend on temperature also. But the molecularity of the reaction will not influence the rate of the reaction. But the rule is that, but the molecularity, but the molecularity of the reaction, molecularity of the reaction mm, does not influence, the rate of the reaction, does not influence the rate of the reaction. So, so now molecularity of the reaction, it means that with how many reactant m- m- molecules will collide with themselves. So which will not influence the rate of the reaction. So option 4 is the correct answer. Then it is told for the reaction A plus B goes to C, it is found that doubling the concentration of A increases the rate by 4 times. So it means that the rate of the reaction, that is equals to K into the concentration of A whole power 2. So it is se- second order in A. Since why, if the concentration of A is doubled, then the rate increases by 4 times. So it means it is K into concentration of A power 2, and doubling the concentration of B also doubles the reaction rate. So it it is directly proportional to the concentration of B. So the rate is pro proportional to the square of the concentration of A, and the rate is proportional to the concentration of B. So then it is told what is the overall order of the reaction. Now therefore the overall order of the reaction, that will be obviously equal to the order with respect to A and plus the order with respect to B. So that will be equal to 2 plus 1. So that is equal to 3. So option 3 is the correct answer. When it is told the rate at which a substance reacts depends on its uh, atomic weight, atomic number, molecular weight, and active mass. So the rate at which a substance reacts, that depends on the active mass of the substance. Rate of the reaction, it depends on the active mass of the reactants. So it means that option 4 is the correct answer. Then it is told that a radioactive isotope has a half-life of 10 days, and if to, today, if today 125 milligram is left over, what was its original weight 40 days earlier? So now it is told that at pre present 125 milligram is left over. So suppose if the atomic mass of the radioactive isotope of the radioactive isotope is m suppose m gram, then we can say that therefore the number of atoms of the isotope, then the number of atoms of the isotope that is left over, that is left over uh, today, that will be equal to 125 into 10 power minus 3 gram by m. So these many atoms, or I can say these many moles will be remaining. So this into the Avogadro number, where Na is the Avogadro number, which is 6.0223 into 10 power 23. So now this I can take it as A. Now since as we know that the radioactive decay is a first order reaction, radioactive decay, radioactive decay is a first order reaction. So I can say that the number of the atoms that is remaining at any time t, that is equal to the initial number of atoms into e power minus kt, where k is the radioactive decay constant. Now let the let here it is told the original weight 40 days uh, earlier. Let the original weight 40 days earlier 40 days earlier, that will be equal to m gram, suppose suppose. So therefore the number of the atoms that were pre uh, present originally 40 days earlier, the number of the atoms that were that were present 40 days earlier, that is equal to a naught, that will be equal to m by m into Na, these many atoms. Since m is, we are saying that it is the atomic mass of the radioactive isotope, or I can say it is the gram atomic mass, or I can say it is the molar mass of the radioactive isotope, that is m gram. Okay. So therefore, as we know that a is 125 into 10 power minus 3 by m into na. That is a, and which is equal to a naught, which is m into na by m into e power minus k into t. Now half-life is 10 days, so I can say half-life equals to ln2 by k, where k is the radioactive decay constant. So k, as we know, k will be equal to ln2 by 10 day inverse. Days inverse means per day. So this will be ln2 by 10 days inverse into t. So which is 40 days. 40 days earlier, so t will be equal to 40 here. So 10 4s are 40. So na by m will cancel out. So this will be 0.125. That is equals to m into e power minus 4 ln2. So therefore we can say m will be equal to 0.125 into e power ln 2 power 4, that is 16. So this will be equal to 16. E power ln 16 will be equal to 16. So m will be equal to 16 into 0.125. So this will be equal to so 16 into 125 by 1000. So 25 5s are 25 4s are 100, 5 8s are 40, so 8 2s are 16. So it is 2. So m equals to 2. So the original weight of the radioactive isotope that was present 40 days earlier, that is 2 gram. 2 gram was present, and at at present we have 125 milligram, which is left over. So it means that option 1 is the correct answer. 2 gram was the original weight 40 days earlier. Then here it is told the concentration of a reactant X decreases from 0.1 molar to 0.025 molar in 40 minutes. If the reaction follows first order kinetics, the rate of the reaction when the concentration of X is 0.01 molar will be. So it follows first order kinetics. It means that minus dx by dt, that is equals to k into concentration of X, since it is a first order reaction. So it is asked that when the concentration of X is equals to 0.01 molar, then the rate of the reaction will be how much? Means then minus dx by dt will be equal to how much? So it means that we need to find the rate constant k. We have to find the rate constant k. Now it is told that if x naught, which is the initial concentration of X, that is equals to 0.1 molar, then the concentration of X is equals to 0.025 molar at t equals to 40 minutes. Then we can find out the value of k. So therefore we can tell that now X is equals to x naught e power minus kt, since it follows first order kinetics. So X is equal to 0.025 equals to 0.1 into e power minus k into t, which is 40 minutes. So therefore we can tell e power minus 40k, e power minus 40k, that will be equal to 0.025 divided by 0.100. So 25 4 is 100. So we can say 40k, that is equals to ln 4. So therefore k will be equal to ln 4 by 40. That will be equal to 2 ln 2 by 40. So it will be equal to ln 2 by 20. So k equals to ln 2 by 20. So K, the rate constant K equals to ln 2 by 20. Therefore, we need to find out minus dx by dt, the rate when the concentration of x is 0.01 molar. So that will be K into 0.01 mole per minute. Since why here the unit of rate constant K will be per minute here. So this will be ln 2 by 20 into 0.01 molar per minute. So this will be ln 2 means it is 0.693 by 2 into this will be 10 power minus 3 molar per minute, and this will be equal to 0.3, 2 3 are 6, 2 4 is 8, 2 6 is 12, 2 5 is 10 into 10 power minus 3, or I can say 3.465 into 10 power minus 4 molar per minute. So 3.47, you can tell approximately 3.47 into 10 power minus 4 molar per minute. So option 2 is the correct answer. Then it is told chemical reactions with very high EA values. EA means the activation energy. So chemical reactions with very high activation energy values are generally very slow. It will be, since why, as we know, the rate constant K equals to A e power minus EA by RT. So if we increase the value of EA, if the activation energy is very high, then the rate constant will be very low. So it means the rate of the reaction will also be very low. So it means that, so high value of activation energy, it means that the reaction is very slow. The reaction is generally very slow. So option 2 is the correct answer. Then here it is told for a reaction A plus B gives C plus D. If the concentration of A is doubled without altering the concentration of B, the rate gets doubled. If the concentration of B is increased by 9 times without altering the concentration of A, the rate gets tripled. The order of the reaction is, the concentration of A is doubled without altering the concentration of B, the rate gets doubled. So it means therefore the rate is proportional to the concentration of A. Since why, if we if we double the concentration of A, then the rate also will get doubled. So it is, rate is directly proportional to the concentration of A. And it is told that when the concentration of B is increased by 9 times, then without altering the concentration of A, then the rate gets tripled. So it means the rate will change to 3R, 3 times. So therefore, the rate of the reaction is proportional to the square root of the concentration of B. It means that, or I can say, rate is proportional to the concentration of B power half. So therefore, the rate is directly proportional to the concentration of A into concentration of B power half. So the order of the reaction is, so therefore the order of the reaction, that will be the order with respect to A plus the order with respect to B, that is 1 plus half that is equal to 3 by 2. So the order of the reaction is 3 by 2. So option 3 is the correct answer. Then it is told which one of the following is a second order reaction. So here the first reaction is a second order reaction. Since why? Here the rate in the first case, the rate of the reaction is proportional to the concentration of NaOH times the concentration of CH3COO CH3. So it means that the order of the reaction is 2. So hence the first reaction is a second order reaction. So option 1 is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter chemical kinetics. And still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section. Also please install our Sapience education application, where we shall upload some more important questions which are based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.